Okay, guys, I'll wait for 5 minutes before I start the class because only five people have joined. Please type the topics that you want me to cover in this class. Okay, guys, I'll wait for 5 minutes before I start the class. Okay, which topic should I cover today? Any particular topic or any particular doubt that you guys have? Particular topic or any particular. Okay, motors and generators. Okay, motors. Okay, only three people here. 2 more minutes. I'll start from 3:30. Let me wait. People perhaps may join later. Okay, so I'll start doing motors now. I'll just download the NCERT content and I'll upload it. Okay, guys, let's start. So, if people are not joining, I cannot do anything. Okay, so electric motor and electric generator is a concept which is based on magnetic effects of current. So, current carrying conductor has so many applications in electrical world, and electric motor and generator are an application of that. Now let me go to motor first. Before that I need to teach you few things. Okay, so before that I need to teach you electromagnetic induction. And what is electromagnetic induction? So there are two things. So suppose I have a current carrying conductor here and there is no current flowing through it. The current is not live. Sorry, the conductor is not live and there is no current flowing through it. Now there was a scientist known as Faraday. Faraday did a lot of experimentation. During his experimentation, he found one particular phenomenon. What was that phenomenon? So a non-current carrying conductor was kept in the vicinity of, suppose, a magnetic pole over here. Now what happened, whenever the distance between the magnetic pole and the current and the conductor is changing, or suppose frequently, or I'm changing the distance between the magnetic pole and this conductor, what was observed that if it is changing continuously, if the distance between the magnetic pole and the conductor is changing continuously, a current is observed in this conductor. It means that change, if I am changing the distance between this magnetic pole and this wire, what am I doing? I am actually changing the magnitude of the magnetic field. If I bring this pole nearer to this wire, the magnitude of the magnetic field will increase. If I take it away from the wire, the magnitude of the magnetic field will change, or it will reduce. So what happens? Changing magnetic field, presence of changing magnetic field in the vicinity of this wire creates, or it leads to flow of a current in this particular wire. So what I'm trying to say is that due to change in the either magnitude of the or the direction of the magnetic field, if a conductor is kept near to that where the magnetic field is changing, you will observe a current in that conductor. But how does that current gets, I mean, how does that current get evolved? The current gets evolved by a process known as electromagnetic induction. So you try to understand magnetic field is anti-proportional to 1 by r square and proportional to I. So or I, or in this case in permanent magnet, the polar strength. So whatever m you can say, so it is proportional to m and it is anti-proportional to 1 by r square. So what happens if I have a fixed magnet? The m does not vary. So what I do is that if I change this distance, magnetic field over here will change, and due to change in magnetic field, what will happen? Across the two sides of this wire, a EMF would be generated. What is EMF? EMF full form is electromotive force, and this is nothing but voltage. So a voltage difference between created between the two sides of the wire, and due to this voltage difference, as resistance is already existing in this wire, V is equal to IR. So a voltage difference is getting created, and I would be equal to V divided by R. And this particular phenomenon of creation of or evolvement of electric current inside a conductor due to changing magnetic field is known as electromagnetic induction. So creation of EMF due to um, changing magnetic field is known as electromagnetic induction. Then there was another scientist, his name was Lynch, and what he did, he told that actually he was trying to prove Newton's third law and inertia, both, basically both. So what he told that in which direction the current should develop. So the thing is that you have already studied that whenever a current carrying conductor is there, it creates a magnetic field around it. So whenever in this scenario also, as soon as the current starts flowing or the current generates over here in this case, this particular current will start producing its own magnetic field. And already I have a magnet here which has its own magnetic field. It means that after creation of current in the conductor, there are two kinds of magnetic field interacting with each other. One magnetic field created due to magnetic pole which was present while I was doing the experimentation, and the second magnetic field would be the field created due to creation of current in the conductor. Now in which direction the current will flow? So always remember that the current would be generated in a conductor in such a way that it opposes the change in the magnetic field due to which this is getting created. I'm again saying it, any particular object will always resist change in it. The what is the change? Change is development of EMF across its two sides, and due to development of EMF, a current flows. But the nature of the current would be such that it will start opposing the magnetic field due to which this current is getting created. It means that the magnetic field of the pole and the magnetic field created by the current carrying conductor would always be in opposite direction. So direction of the current would be in such that the magnetic field created by it is in opposite direction of the magnetic field created due to pole. That's what we have to understand, and this is what Lenge's law is. So after I teach you Lenge's law and all these things, so there is one thing which is uh, with which you can find out the direction of the magnetic field here, and that is, or direction of the current here, that is Fleming's left hand rule, sorry, right hand rule. So there, your index finger would be direction of magnetic field, your middle finger would be direction of current, and your thumb would be direction of motion, which is nothing but direction of force also. So that is what the concept is. Now, what is the concept of generator? So I have an alternating current generator, or it is also called dynamo. So alternating current generator is also called dynamo. Okay, so what is the concept? So if you have your book, just go through the construction and all. What happens is that I'll explain you in very layman term. So I have current carrying conductor, and in what type I have current carrying conductor, because I have to, I mean, if it is a generator, AC generators means what? Input is AC or output is AC. As the name suggests, AC generator means AC current generator. It means that output current after creation of electricity would be a AC current, would be an AC current. So AC generators always produces AC current. Is it okay? Or and then there comes, how do you construct it? So here I have magnetic pole, and how do I create magnetic pole? So on two sides of the conductor, the current carrying coil would be rounded on a core. Is it okay? And that core would be fixed between, it will not be fixed, the core would be free to rotate between two fixed magnetic pole. So try to understand. Here is my magnetic pole. This is magnetic pole. Suppose this is North Pole and South Pole. And here with a shaft, I have cylindrical core, and on this core, current carrying conductors has been coiled like this. So this is a current carrying conductor. And now what happens? This particular core where the current carrying conductors are rounded up is combined with a rotator. So what happens? Why it is combined with a rotator? So try to understand. My objective would be, I know that by Faraday's law, if there would be a changing magnetic field in this current carrying conductor, current would be generated, and I can utilize that current as output. So what I do, these poles are fixed, so I cannot rotate pole. What can I rotate? I can rotate this particular core which contains iron. Just give me a moment, guys. Presents winter travel sale. Okay, so what will happen is I cannot rotate this permanent magnet. They are very heavy, and rotating it is very difficult. What I can rotate is this core on which this coil has been wrapped up. So how do you rotate this coil? So coil is joined with a rotator. Is it okay? This rotator is rotated with the help of so many things, one being steam. So rotator, you have fans. On the fans the steam comes and strikes the fan. Due to the energy that the steam carries with itself, it when it strikes with the fan of this rotator, the fan starts moving. As soon as the fan starts moving, this is coupled with this core, the core starts moving. As soon as the core starts moving, what happens is the direction of the magnetic field at each point will keep on changing. As soon as the direction of the magnetic field and the magnitude of the magnetic field changes, what happens over here is that there is a change in flux. Now I forgot to define flux. What is flux? Flux is number of magnetic field lines cutting any particular area, any particular unit area. So number of magnetic field lines cutting per unit area, or number of magnetic field lines passing through per unit area, is also known as flux. So what happens is, as soon as they'll start, this will start rotating, the flux will change. Due to change in flux, what will happen? Suppose this is one end of the conductor or wire, and this is the second end of the wire. So what will happen? The current will be generated here. The current would be an AC current generated, and this current would be taken outside somewhere here, and this will be passed on. So AC current is nothing but a AC generator is nothing but an example of electromagnetic induction. How do we apply electromagnetic induction here? So we know that changing or varying magnetic field will be able to create EMF around the two sides of the coil. So here what I am doing, instead of changing the magnitude, I am rotating it so that primarily the direction at each point of the conductor changes. As the direction of the magnetic field created by the poles is changing on each point of the conductor, due to change in flux, EMF would be generated. Due to that EMF, the current would be generated in the circuit, and that current would be received outside and would be utilized for different purposes. So that is how it is. So did you understand electric generator, guys? Just post yes or no. Did you understand electric generator? Tell me, otherwise I'll repeat once again. Param, did you understand? Okay, now let me move to motors. So what is a motor? So generator is conversion of mechanical energy into electric energy. Motor is exactly different. Motor is conversion of electrical energy into mechanical energy. So it means that, okay, here where is split and split rings? Can you just, okay, fine. In motors, right? Here the split rings and all. Yeah, in motors you are asking, or in generators? Because I don't have figure which book you are referring. I cannot understand. So if I have the NCERT book where in electrical motors or in motors split rings and all are used. Okay, I'll explain. Once you let me know, I'll explain. Okay, so what happens is, once again, let me draw a figure. Okay, so what I'm doing is I will upload a few pictures here. Okay, so look at this image, what is happening here. I'll upload one more image. So see what is happening. There are two images which I have uploaded on the screen. One which looks like a motor, and one which is an experimentation. So rings and brushes are like this, which are nothing but which will provide support to the coil, and which will control or which will receive or either send the current to this coil. So if current is coming out, it will help in receiving the current, and it will maintain the contact properly. And also if the current is going inside, again it will maintain the contact easy, or in a very smooth manner, and let the current pass in the conductor. So that is the use of it. Now how does motor works? What is the principle of motor working? So there would always be a source battery or a source of power. Uh, I already told that a motor is a device which converts electric energy into mechanical energy. It means that motor input would be electric energy. So from where does electric energy comes? Electric energy, passive electric energy would come from any battery. Like here I am using passive electric energy in the form of battery. Or in case of active electric energy, I can join the two sides of the coil with some AC or DC current which is available. So like in home, if I want to connect motor, like we have motors in for our water purposes, and also though they are AC motors which are working over there. So what I do is that I take input from any of the circuit present in my house, and I connect the two ends of the coil which is present inside the motor to that AC input, and due to that AC input the motor starts rotating. How does it rotate? I'll explain you now. Now what happens? So if it is connected to any particular energy source, in this case battery, so what happens when circuit gets completed? A current will start flowing through this conductor. So you can see, suppose I name it ABCD, so ABCD. So current is flowing from A to B, B to C, C to D, and likewise. So what happens is, what happens is, because there is a current carrying conductor, and this is, see what has been kept over here. This is nothing but your magnet. So what is happening? I am giving it a particular, try to understand guys, I am giving it electrical energy. So current would be I over here, and an external magnetic field is present due to this particular magnetic pole. So what happens? We all know that whenever a current carrying conductor is placed inside an external force, a force would be applied on that conductor. So here some amount of force would be applied on different arms of this conductor, and because a force is getting applied, so see here direction of the force has been made. Direction of the force is this side. On this particular coil, direction of the force is on this side. So what will happen? Due to force being applied on these coils will feel some amount of momentum, some amount of torque. Due to that torque, this will start rotating. As soon as it will start rotating, its shaft would be, so look at here, this starts rotating. So when it starts, stator means there are, so look at here, there are two parts, stator and commuter. So what happens? What is commuter? Stator is your this part which is creating your magnetic field, and here I have given input, and as soon as current starts flowing due to force applied on the current carrying conductor, this will start moving, and this moving part is known as commuter. So this is what the principle of electric motor is. Any doubt guys? Tell me. Any doubt? Ask questions. Okay, fine. Any other doubt that you have? Param, you have any other doubt? People ask me motor and generator. I have already explained it. If there is any other doubt, guys, let me know. In any particular topic, should not be related only to magnetism or electricity or optics. Any topic that you have doubt, ask me. I'll revise it. I'll not waste your time. I know you have other exam. So whatever doubt you have, I'll clarify it and wrap up the session. Yes, Param asked me. Oh, great question. Why it is easier to transmit AC current? So try to understand, Param, whether it is AC current or DC current. It depends on the amount of current which is getting transmitted. So suppose, let me, so what happens in this case is that first thing is magnitude of the current. So suppose what happens, like I was working in a power plant, and that power plant used to generate 165 megawatt of electricity. So voltage would be whatever is voltage. I mean, vi cos theta is total 165 megawatt. So, suppose current produced is some 50 amperes, for that matter. For your understanding, just I'm saying 50 amperes, or maybe 100 amperes, or 2000 amperes, or likewise. Now try to understand, if it is DC current and if it is AC current, how does it differentiate from each other? So suppose I have two power stations near to each other. One is producing 2000 ampere DC current and one is producing 2000 ampere AC current. Now I know that the power losses due to transmission of electricity is I square R, which means that if I am using same material for transmission for both DC current and both DC and AC current, then I am removing the R value also. The power loss I square R would be directly proportional to the current flowing over here. So if both the currents are 2000 amperes, then the power loss in both the circuits or both the transmission lines would be same. But what happens generally in AC current, we don't let the current to be too high. How do we reduce the amount of current to be transmitted? We use a transformer. Now, what is transformer? Transformer is a device which has an input and an output and a core inside. It works in such a way that the power transmission remains same on both the sides. It means that whatever power it receives from input side, the same power it delivers from output sides. Hence power loss is almost zero. Now you can say that how it is possible. So try to understand that. Suppose this is the primary side of the transformer and this is the secondary side of the transformer. So this is like this, and primary side is taking voltage V1, and suppose current here is I1. So secondary side here is voltage V2 and current is I2. Suppose number of turns in the coil is N1 here and number of turns in the coil is N2 here. So I1 by N1 is equal to I2 by N2. So I2 is N2 by N1 I1. So it only depends on how many coils, how many turns in the coil one side has. So suppose if secondary side has more number of coils, if N2 greater than N1, then I2 would also be greater than I1. So what happens? I have more current here. Now in opposite case, if N1 is greater than N2, then I1 will be greater than I2. So what I do is that a transformer is a device, and the relationship is power is same. So V1 I1 is equal to V2 I2. So what happens when I have more number of turns here and less number of turns here? So the current generated in this particular circuit would be lesser than the current in primary circuit. Hence, stepping down of the current is easier for AC current. DC current cannot be stepped down. DC current cannot be stepped up. Suppose you are producing 2000 amperes, you will have to transmit 2000 amperes, and hence your power losses would be too much. If you are producing 2000 ampere AC current, in that particular scenario, stepping down this current and bringing down your power losses would be much easier with the help of transformer. That is why in power transmission AC current is used. Any other doubt? Ask, guys. What are you guys doing? You have no doubt in physics. I can start asking different question, and then you will say this is the doubt, that is the doubt. Param, did you understand? Yes. Energy is conserved. So what happens, Param, is when suppose V1 is 200 and I1 is 10. So power on this side is 2000. So if I make current 5 here, this will automatically become 400. So what happens is energy is conserved on both the sides. So if 2000 it is here, it will be 2000 on the other side. If current is reducing here, voltage will increase. If voltage is less here, voltage would be more, and if current is more here, current would be less here. So that is how, yes, the voltage will increase on the other side. So this will be the condition. V1 I1 is equal to V2 I2. So if there is a reduction in current, the voltage will increase. So we always transmit the power at more voltage and less current. Why less current? Because I want I square R losses to be less, and hence we reduce the current. Any other doubt, guys? Please ask me. There is no point doing something new in this class. Ask the other doubts, because I can take any topic, start teaching you, and you will feel bored if you don't have doubt over there. Post your doubts. Otherwise, go and study if you don't have any doubt. What do I need to do next? Okay, let me give you a question. So write down a question. I'm just orating it. Write down the question. The question is, find the magnetic field. Find the magnetic field at a distance of 10 centimeter from a long straight conductor carrying a current of 10 ampere. A, a long straight current carrying conductor is there which is carrying a 10 ampere current in it. You have to find out magnitude and the direction of magnetic field 10 centimeter east of the magnetic field of the of the current carrying conductor. What's the answer? Question is, there is a long straight current carrying conductor. It carries a current of 10 amperes. You have to find out magnetic field at a distance of 10 centimeter and direction also. The point at which you have to find out the magnetic field is 10 centimeters east of the current carrying conductor. Did you find the answer? No, it's not 2 into 10 to the power minus 7. Perhaps you have not converted centimeter into meter. Just convert, Param, just convert centimeter into meter. Did you get the answer, Param? It will be 2 into 10 to the power minus 5. No, minus 5, Param, just do it. See, the formula is, acha, you got it. Okay, great. For others, the formula is B is equal to mu naught by 2 pi I by D. So I would be how much? I would be 2 into 10 to the power minus 7. Sorry, mu naught by 2 is 2 into 10 to the power minus 7. I is 10 amperes and D is 10 into 10 to the power minus 2. So this 10 10 gone. This 10 to the power minus 2 will go above and we will become 10 to the power plus 2. So this will be nothing but 2 into 10 to the power minus 5, which is nothing but 20 into 10 to the power minus 6. So which is nothing but 20 mu t. That is the answer. Second question. Second question is I'm orating the question. Find the ratio of magnetic field at a distance 5 centimeter and 50 centimeter from a long straight current carrying conductor. So there is a long straight current carrying conductor, and you have to find the ratio of magnetic fields at 5 centimeter from it and 50 centimeter from it. So suppose 5 centimeter from it, the magnetic field is B1, 50 centimeter the magnetic field is B2. You have to find B1 is to B2. Just solve it. What's the answer? This is so easy question. Tell me the answers. The question is, there is a long straight current carrying conductor and there are 2 points. One is 5 centimeter and second one is 50 centimeter apart from it. The magnetic field at 5 centimeter point is B1, at 50 centimeter point is B2. You have to find out B1 is to B2. One answer which I am getting is 10 is to 1. What is the second answer? Anyone who is getting the answer? Okay, 10 is to 1 is a right answer. So you look at here, here only B is anti-proportional to D. So B is anti-proportional to D. It means that B1 or BD is equal to constant. So B1 D1 is equal to B2 D2. So B1 by B2 is equal to D2 by D1. D2 is equal to 50. D1 is 5. So this is 10. So 10 is to 1 is the ratio. As simple as that. Okay. So any other doubt that you have, guys? I have solved 2 questions. If you have any other doubt, let ask me. Otherwise, I'll wrap up the session now. Any particular doubt in optics? Let me ask section wise. Any particular doubt in optics, electricity? Just post it in the chat box. Okay, Param is saying nothing else. Anyone else? Do you have any doubt? I'll wait for 1 minute, otherwise I'll wrap up the session. Okay, fine. Nobody is speaking, so I'll wrap up the session.